Algebra I Chapter 3, Section 6, solving compound inequalities. So our objective is to solve compound inequalities in one variable and graph the solution sets of compound inequalities in one variable. So first off, what the heck is a compound inequality? When two simple inequalities, like x plus 3 is greater than 3, are combined into one statement by the words and or. Then you have an intersection. An intersection is the overlapping region in a compound inequality. And a union shows the numbers that are solutions of either inequality. So let's get started. When it comes to compound inequalities, I do want to talk about one thing before we actually get started. Do I have any room here? I have a little bit of room. So your ands on a number line, say you have 1, 2, 3. Your ands are going to be your dots. Sometimes they're open, sometimes they're closed, but it's going to be between them. So ands enclose an area, whereas ors go away from each other. So it's either and, so you can get everything in there. That's what and means. It's to include things. Or you have an or statement, which means it could be one thing, or maybe it's not that thing, maybe it's something else. It could be on either one. If we were going to look at example 1, it says a water analyst recommends that the pH level of swimming pool water be between 7.2 and 7.6. It's got to be between these two numbers. That's where the pH needs to be. Write a compound inequality to show the pH levels that are within the recommended range. Graph the solutions. So we have 7.2 has to be less than or equal to whatever our pH is, which has to be less than or equal to 7.6. So if we were to show that on a number, we would show it like this. We know we have to have 7.2. We have a decimal in here, so now we can do 7.3, 7.4, 7.5, 7.6. So if we were to graph that, so since it's less than or equal to, it has to be equal here to 7.2 with a closed dot, and 7.6. And because it's between 7.2 and 7.6, that and statement has to be here, so between the two. Example 2. So how do we solve something that looks like this? Well, we still want to get x by itself, just like we have before. So what's with the x? It's a 2. What's it doing? It's adding. So we're going to do the opposite. We're going to subtract it to get it across the inequality. The difference between what we've been doing in this is that we don't just subtract it from the inside and one of the outsides. We have to do both of them. So you get 2 less than or equal to x less than or equal to 6. This is considered an and statement. When we come down here, you can see it when we do our number line here. So I'm going to do 1, 2, 3, 4, 5, 6, 7. I did a number to each of, to the left of 2 and one to the right of 6, just so we would have everything in here and you can see what's going on. What we have here is you can break this up into two inequalities if you need to. It's that x is it's eating the x, so it keeps eating the x even when I change it out, and it's not eating the x here, so it's less than 6. On that one, you can just leave it. So we would need to have a closed dot at 2, and we need to have a closed dot at 6. So this says x is greater than or equal to 2, which means it goes this way. X is less than or equal to 6, which means it goes this way. Because it's this and statement, x is greater than or equal to 2, and x is less than or equal to 6, that means we need the area where they overlap, which is here. So where we are actually coloring in is between the two. That's our answer right there. Get rid of that. So there is your answer for your number line. If we were to do another one, we want to get x by itself, so the first thing we need to do is subtract 3 from both sides. We get negative 8 less than or equal to 2x less than 6. Then I need to divide everything by 2. So I get negative 4 less than or equal to x less than 3. So I need negative 4 to 3 on my number line. 4, 3, 0, 1, 2, 3, 4. I need a open dot at 3. I need a closed dot at negative 4. Now, it's easier for me to read if my variable's on the left, so I already know that this one's set up correctly. So now I just have to flip this other one, so x greater than or equal to negative 4. So x is greater than or equal to negative 4. X is less than 3. That means that I need to fill in between the two. Right there. So that is how it should look for our graph. That is their intersection, by the way, going back to our word from the beginning. So example 3, here we're dealing with ors. If you remember, ors go away from each other. So let's solve. So plus 4 plus 4, so you get a is greater than 5, or you add 4, and you add 4, you get a is less than 1. On my number line, 0, 1, 2, 3, 4, 5, 6. I need to have an open dot on 5. I need to have an open dot on 1. So a is greater than 5, means that it goes to the right. A is less than 1, means it goes to the left. And there's our or statement. So here we have a union. The combined regions are called the union and show the numbers that are solutions of either inequality. So this is a union, or before we had an intersection. Here's another one. Divide by 2, so we solve. So x is less than or equal to 3. Divide by 3. X is greater than 4. We have two numbers here. 2, 3, 4, 5. We have an open dot on, or closed dot on 3. Open dot on 4. So x is greater than 4. Shade to the right. X is less than or equal to 3. Shade to the left. Example 4 is doing the opposite and actually forming our compound inequalities. So you can look at these, and you should already be able to tell me that this is an or, because they go opposite, and this is an and, because they intersect. That's why it's an intersection. So for this one here on the left, x, I need a variable, I need a number. It's shaded to the left, which is less than, and it's a closed dot, so it's less than or equal to. Here, the one on the right, I have x and I have 7. It's greater than, and it's greater than or equal to because it's a closed dot. So when I write this as x less than or equal to negative 1, or x is greater than or equal to 7. That's how you write it. It's finished product. Then on the other one, we can say that we have x and 0. So this is shading this way, so that's greater than. Then we have x and 6, and it's shading this way, so it's less than. Now the question, over here with 0, it was a closed dot, so it's greater than or equal to. Over here at the 6, it's an open dot, so it's less than. So if I were to switch this around, because it's an and, we do like to see it in one statement. 0 has to keep eating the x. See if this works. And it does. So x is between 0 and 6. That's what we're saying here. You can write it like this. You can put a big and in it. It would be helpful if you started to remember how to write something in this compound statement. And our homework is on page 206. We're going to do 16 through 27, starting with number 16. Negative 1 is less than x plus 1, which is less than 1. Solving this for x. So we get negative 2 is less than x, which is less than 0. Your line here. Negative 2 and 0. You get open dot at negative 2. You get open dot at 0. So x is greater than negative 2. And x is less than 0. So that means we color between. And there is our answer.